Happy Friday. Oh, are we there? Live now, I guess. All right, happy Friday, everybody. It is September 27th, 2019. We're going to finish. Oh, it is a little behind. All right, we're going to finish up the software. So, assuming you've seen the first part of this tutorial video, we talked about um, the schematic and the board, and we got a little bit of the software. We're going to kind of maybe back up a little bit and just do the software from the get-go in case you didn't watch the end, and if you're interested in just looking at the code. All right, so the background is open escape rooms, different gadgets. This one we're making a gadget that will give you the functionality of when you put like the 3 candlesticks on the mantle and the RFID is inside the objects, and then there's readers where you have to sit them in the right place, and then it opens up a lock or opens up a relay, or something happens based on getting the right combination of objects into their proper place. So let's just go ahead and dive right into the code. Again, I think if you go back, if you watch the first one, that'll explain a lot more of what we're trying to do. This is just this is probably a work in progress. There's still more. I'll probably go back and rewrite a little bit of this, but I think it's pretty good for where it's at, for where it needs to be, and I think it'll help if you're coding projects, especially if you're trying to create multiple instances of, say, instead, it's one thing to use one RFID reader, but if you want to use 2 or 3 or 4 RFID readers, so anything where you're declaring a class, an instance of a something like this PN532 RFID, what's a way that you can make the code small and easy to read without having to create make your code condensed when you have a variable amount. And so the same thing here is, you might take this code and you hook it up to 3 readers. Someone else might do 4 readers. Someone else might just do 2 readers. So try to write the code so that's literally just you change some of the variable numbers, and then the code reworks regardless, and it's still clean. So with that, the first thing I always do is put all my libraries that I'm including up at the top, and I'll also, of course, a little intro about what the code does, and if you're using anyone else's libraries, give them a shout out. And so that's what we've done here, because this is all based on Adafruit's library for their 532 RFID product they sell. And why is it a little off? All right. So I talked about last time how you can do debug printing, so that you don't have, when you're using print lines, instead of using the serial print in your code, how you can turn that, basically real quickly turn that on and off, so that when you're doing testing, you can have all your serial communication, but if you go to actually run this thing, then you can turn it off, because, for instance, this device, there will be no display when it's actually being used in an escape room. So there's no need to actually waste time printing out messages to the serial port that no one's going to read. So this is how you can create like a debug switch. If you do #define debug, basically saying if debug is defined, then we're going to define a new thing called debug print. And we're doing the same thing for print line. So this prints with not a new, so debug print just prints, and then debug print with a new line prints and then returns to a new line, so that, and we use both. And for instance, so if I didn't want to print, so right now by #define print, this will happen. If I'm like, okay, I don't want to print anymore, I can just comment out the pound define, and then it's not defined, and therefore I won't be doing any sort of printing to the screen. Let's take that out real quick. All right, moving on. So, in theory, you can use this code on different architectures. So instead of just using, if you've seen the Arduino tutorials, they just say like int, but I'm being specific on the so it's architecture kind of independent. I guess that's the best way to describe it. I'm being very expressive in what type of int I'm declaring here, and const means that it's not really a variable. It's now like constant. This number does not change. There's no way for this number, for this variable num underscore readers to get changed in the code. So this is the first thing you have to change. If you want to have 3 readers, you make this a 3. If you want to have 4 readers, you make this a 4. Or if you just want 1 reader, you make it a 1. Then we have our hardware assignment to the pins. I always end everything underscore pin, underscore pin, underscore pin, just so I know, okay, this is a pin. Same thing, don't want it to ever change, being explicit. So, the serial clock pin for the PN532, each board has at least 4 pins, each reader, and they share, all the boards share at least 3 of the pins. Serial clock, master in, slave out, master out, slave in. These are all shared for all the boards, and then each one gets its own select pin. So when I want to talk with one of the first one, it's going to raise pin 8 high. When I want to do that with the second one, pin 7. So pin 13, pin 12, pin 11, 8, 7, 6, 5, 4. I always try to put them in order as well. Then we have some outputs. So the when the boxes, when the puzzle hasn't been solved, the closed LED will be high. When it's solved, the open LED will be high. And then we're also giving folks the option to have a pulse width modulate, basically an analog out, and that'll be on pin 3. So these 3 are all related to outputs. All right. Then you have to get a read the tag. There is, I think I talked about it last time, there is an app on your phone that you can scan these RFID readers, at least on an Android phone. I think it's like NFC reader. Usually you'll get a hexadecimal number. Then you convert that to a decimal. There's tools, there's websites to do that too. We need the decimal, not the hexadecimal. And again, if you want 3 or 4 tag readers, you just uncomment and then stick in the tag IDs for those other ones. Again, when the device is locked, we'll have pulse width modulation will be low, and when it's open, it goes high. I guess in theory you could change this around by just changing the numbers around. The value, it would be a little bit harder. Maybe I'll rename this to be like pulse width modulation value locked and unlocked. Maybe I'll make that a little more sense in case you want an active low kind of thing. All right, a delay amount. So for the few times I use a delay, instead of again saying 1 millisecond, I give it an amount so I can change it really easily, not to go through and look for every time I have a delay in my code. I can just change it once. This is a little state. We talked about like the state machine. Basically, there's only 2 states. It's things either locked or not locked. We start it as locked, so is locked is true. Here's where we get into a little of the creative part of the code that may, or at least maybe if you've never coded all before, you might not understand what we're doing. So we'll spend a couple times on here. So what I'm saying here is I'm creating this. So slave select pins, open bracket, num readers, is basically I'm creating an array. I'm going to create an array where I'm going to store the pin numbers that we wrote up here. So right now I'm set up for 2 readers, so I'm only going to have select pin 1, select pin 2. Again, If I wanted 3 or 4, I would add those in here. But this gives me a way, you'll see down the code later, I can step through my pins by simply incrementing a counter instead of versus calling every pin individually. I think that'll make a little bit more sense when we get down to the code. But I do the same thing with the accepted tags. Oops, there we go. I'm going to create an array that's of size number of readers I have, and I'm going to initialize it with tag ID 1, tag ID 2 in array position 0 and array position 1. Again, if I wanted more RFID readers, I would put them in here 3 and 4. All right. Now, Adafruit PN532. This comes from my library that they provided for their PN532 RFID readers. So I'm declaring an instance of that, but I'm not actually declaring an instance like you normally would see. I've got this little star here. What I'm doing is I'm creating a pointer, and I'm actually creating an array of pointers that point to Adafruit PN532 objects. So basically, I'm not declaring the actual reader. I'm creating a place where I can point to the address of it. Basically like an address book. I'm creating an address book of up to num readers, which again is 2. Oops, I keep pressing the wrong button. And you're going to see this. This is what gives me the flexibility to make my code variable without having to write a lot of code down in the actual code itself. You notice it's only 229 lines of code. My first go through with this, when I was doing it without an array, it was like 4 or 5 times, because basically every reader had its. I was duplicating the code too much, basically. So we're using a pointer. And then this is also useful when they don't give you a way to, when the library doesn't give you a way to initialize, when you have to, basically, when I have to initialize in the setup, and I don't know how many I have. Well, I mean, I'm going to know how many I have, but the code, I want to create this code to be generic enough. Bottom line, the pointer, an array of pointers to the Adafruit PN532 object is going to allow me to dynamically scale at compile time. So again, if you come up here and you change this to 3, you got to compile it, but the code will work. There's basically nothing in the code itself. Basically from line 82 down, nothing changes. You don't have to go into the code to change anything to make it work with 1, 2, 3, or 4 readers. All right, so let's get into the setup function. So I'm going to start my serial, my baud rate. Now, again, depending on how I set my my pound defined for debug, will decide whether or not this line fires. So right now it would fire because I'm still in testing. All right, so the first thing I need to do is initialize. I'm going to do a lot of initialization. So I'm going to use a for loop that runs for the number of readers. So if I've got 3 readers, this will run 3 times. If I've got 2, it'll only run 2 times. So NFC readers, again, this is that array. This is that pointer array. I'm pointing to NFC and an address where a NFC reader object sits in memory. I'm going to do it one at a time. So this is the first time this runs through. It's NFC readers at 0. So basically RFID reader number 1. I create a new instance. I give it these. This is, again, if I was doing this, if I was writing this code and only had 1 reader, I would just go Adafruit PN532, give it my name, NFC readers, and I would pass along all the pin setups. And again, remember, because we've got each device shares the clock, master in, slave out, master out, slave in pin. Those are constant. But again, because each one has to have its own select, again, this is where the array comes in. This is why we did up here, we made this an array, and we initialized it with the pin for the first, the second, the third, the fourth reader. So now that will get created, and an address. So we'll store in this array the address to this PN532 object. And then I will begin it, and then the delay, but I took that out because I don't think I really need it. Grab its version data out of off the board to just check to see what version of the firmware it's running. This is optional. You could actually delete all this if you didn't really care about that. Then a couple debugs. I'm going to go ahead and say, hey, I found one of those PN532s. I'm going to get the version information, print that out, and basically next thing is this is sending it the configuration per the Adafruit PN532 library, and then next we're setting it basically you get one retry, listen once, and then go then exit out and go to the next reader. If you didn't set this, it would sit there, and the first reader would sit there and wait forever until it saw a RFID tag go past that reader. So by saying set the value to 1, basically it lets us be able to walk through each reader and one at a time. If you notice that it only looks at one reader, check this. This is what you may have missed if you're running your own code from scratch. All right, then we're going to set the outputs, our output pins, to outputs, and then we're going to go ahead and call a function that actually initializes them. And then once that's done, this is probably needs to be tagged back out. There we go. We give all the way through. So if all this is passed and we've gotten any failures, then the system is ready to go, and it's basically live. And so let's go down here real quick to the set device outputs function real quick. That's at the bottom. All right. So what we're going to do is basically give a 3-second countdown, and then we're going to basically toggle the LEDs. So basically, to give a visual alert to the person that's setting up the escape room that okay, you plugged it in. Get ready. You get 3 seconds to actually make sure everything's closed, everything's locked, whatever you have to do. So we do a quick 3-second alert. We flash the LEDs high, and then we go ahead and we set the pulse width, the analog output to low. We set the open LED to low and the closed LED to high, and then the system is initialized. So at that point, if it's a relay that you're driving, it's locked and the door should be closed, or whatever you're tying your output to, the game is ready to be played. So then let's go into the main loop. And again, it's not that long. It's actually, a lot of it is just, we could actually clean this up a little bit and actually make it a little bit simpler. But, so the thing we do in the loop, the first thing we checked is, hey, is this thing still locked? Have they already broken, have they solved the puzzle? Because if it's so, then we can just basically do nothing. There's no sense doing anything. But so long as it's still locked, they haven't solved it, we're going to go ahead and we have we're going to basically, every time, we're keeping like a scratch pad, and every time we run through the loop, we kind of clear it out and we start again. So we say, okay, we're going to store the tags that we read this time through. So we need an array of that, because there could be anywhere from 1 to 4 readers, and there's going to be 1 to 4 tags we need to read. So we're going to store those in an array. And then we're going to keep a count of how many of those match against the ones we're expecting. So then we're going to go ahead and clear out, basically, because every time we go through, it we want to clear out, because if they've moved things around and they're now things on the wrongs, they've moved a candle around to the wrong spot, we don't want to give them credit for getting it right at once. They have to get all 4 or all 3 or all 2 right at the same time. So we're going to clear out what we read last time. And then we're going to go ahead and do a current read. So again, for as many, we're going to go through this loop, this number of times there are readers. We're going to have a way to store if the success. We're going to have the device's ID. We're going to store that in a buffer. We're going to get the length of that, and we're going to get then we're going to convert that into an integer, a 32-bit integer, as the card ID, and that's what we compare against. So this lets us talk byte by byte with the card reader, and then we store it finally in a 32-bit. Same thing. I go ahead and print out my debug messages. So now I'm going to go ahead and do a read. So NFC reader, the first reader, to a passive read. I'm going to pass it the type of card I'm expecting. I'm going to pass it the UID, the array, the buffer to store it, and then the address of the length. This is passing by reference. So we're not actually passing the copy of it. We're actually passing an address that stores UID length, and we'll use that in that function. And again, this comes from the Adafruit library. I didn't write this one. Okay, so so this function returns an 8-bit int if it's successful, and I think it sends back a 1. So if I am successful, if what I got back from that library, or got from that, if I actually read something, and I will go ahead and basically decode it. So if I did read a tag, say, hey, I found a card, and now I make sure that it's the right length. If it is the right length, then I can start to decode it, put it into basically I'm doing reading 1 byte at a time, putting it into card 8, and then shifting it down, so least significant up to the most significant bits, shift them over, or in the next byte, shift it down, third byte, shift it down. So then by the end, I'll have 1, 2, 3 bytes for 8 times 4, 30. I'll have my 32-bit tag ID or card ID. And then I just go ahead and store that number into my array of red tags, and I wait a little bit just to give myself a little pause. This is the end of the loop. So this loop runs however many times there are number readers. So again, right now I've got it set up for 2, so I'm going to go through this loop twice. If the players have put the right RFID tags at the right spots, at the end of this loop, I'll have the correct tags stored in the array. And when I get to this next part, I'm going to go through and basically compare the red tag to the accepted tag, so the tags I read, to what I am expecting. And I'll notice a little bit here, when it's a variable, things that are variables for me, I do like lowercase, uppercase, like it's called a camel hump or whatever. So lowercase, then an uppercase of the next word, and then the next word is uppercase. And the fact that it's this way lets me know it's a variable, whereas NFC _ accepted _ tags, all caps, I know that this is a constant. So the things in this array should not be changing. The things in this array should be changing, and that makes sense. This is where I'm storing each time I go through the loop, and this is the things I'm expecting, which should be constant. Every time it does match, I increment the count of matching tags. So if, in this case, if I have 2, I should get to 2 tags match. And so down here, I go, once this loop goes through and it checks it goes through the arrays, checks every tag, against what I was expecting, and once it's done that, I should have that number, the count of matching tags, should equal the number of readers I've had, because every reader should have the right RFID tag against it. And if I go ahead and I match, that means basically the player has solved the puzzle correctly. I can activate my relay. Again, I could change it to something different. I was thinking it would be a relay when I wrote this initially. And all we do here to activate relay is print out a message, alert, 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 all tags correct, activate relay, and then we just toggle the outputs. So the analog, we turn the pulse width modulated analog signal, we turn it to high, we light up the open LED, and then we turn off the closed LED, and we set the status of our device to is locked, is now false. So when we go back into this main loop, none of this will now run, because we've already, oops, don't want to do that. Is locked is now false. And that's the code in a nutshell. Let me think. Is there anything else I'm missing? Oh, to reset this, there's no need for a code way to do it, because if you remember back to our schematic, we've actually we have a screw terminal here that connects to the reset pin. So you could put two wires in here, run it to a push button, and that way the person that's running the escape room, as they're cleaning the room and putting it back together, and they've got to reset this particular puzzle, all they have to do is push this button and it resets it. Now, you got to be kind of careful to where you put that. You might run that wire to a spot outside of the room, so that the players aren't accidentally pressing it. But it's there, or you could put a sticker that this is not a part of the game, don't press this button. I'm not sure exactly what, but the point is, we give you the option to do that. That way it's kind of easier to reset it. I'm assuming if this circuit board gets molded into something or installed into something, it's a pain in the butt. But you could, it's just as easily, you could just pull the power. But we wanted to give it a nice, an easy way to do a reset with a button. And that's it. So that's the code. We're going to come back on the next installment in this series, part 3. We'll do something where we'll make an enclosure for this device, along with the Arduino Uno that it would sit in. So I guess, yeah, so that'll be next, and that'll probably be out in a week or two. Just I don't have a lot of time between now and then, but that's the plan at least. So any questions, hit us up, leave them in the comments. We'll get back to you as best we can. And with that, thanks for listening, thanks for watching, and we'll see you next time.